Chapter 3, Section 1, Radian Measure. So in this section we are going to talk about a new term called a radian. And so let's understand what the definition of a radian is. And you can see this in your books on page 102. But an angle theta, we've talked about angles in the previous two chapters, so we know that an angle theta with its vertex at the center of a circle that intercepts an arc on the circle, so here's your arc on the circle, equal in length to the radius. So basically what happens with this angle, if you have an angle that intercepts an arc on a circle, and that arc is equal to the radius of the circle, then you have a measure of 1 radian. So when your arc is equal to your radius of your circle, then you have 1 radian measure. And so radian measure allows us to treat the trigonometric functions as functions with domains of real numbers instead of angles, because as of right now we've been talking about our domains being from like 0 to 360 degrees or 0 to 90 degrees or something like that. So here are some conversions that we've already talked about. We know that 1 degree is equal to pi over 180, and therefore 1 radian is equal to 180 over pi. And so if we go to our quadrantals, we know that this is 0 degrees or 360. Well, 0 degrees is the same as 0 pi, and 360 is the same as 2 pi. And then 90 degrees is the same as pi over 2, and all we're doing is making a conversion. 90 times pi over 180, you're going to get pi over 2. Same thing, 180 degrees is equal to pi, and 270 degrees is equal to 3 pi over 2. And so we are going to work on these conversions, and we're going to talk a lot about radians in this chapter. So converting between degrees and radians. To convert to radians, you're going to multiply a degree measure by pi over 180 radian and then simplify. Radian measure should have pi in the answer. Keep that in mind. If it asks for radians, then you should have pi in your answer. If a whole degree measure is given. If decimal degree or degree minute second is given, then you're going to use 3.14 or pi on your calculator to find the decimal answer. So decimal degrees, that's okay. Okay, so to convert to degrees, you're going to multiply the radian measure by 180 over pi and then simplify. Degree measure should not have pi in the answer. So again, if it's asking for degrees, you don't want pi in the answer. If it's asking for radians, you do want pi in the answer. Okay, so let's try this. Convert each degree measure to radians. So if we're starting with degrees, remember we're going to multiply by pi over 180 degrees. And so degrees will cancel out and you're left with the pi. And so we can reduce, understand this is 60 over 1, so 60 will go into itself 1 time, and 60 will go into 180 3 times. So that's going to be pi over 3. So 60 degrees is the same as pi over 3 radians. Okay, so 135, same thing. We're going to get rid of degrees, and we want it in terms of pi because we're transferring it into or converting it into radians. And so what we're going to do is we're going to reduce this. Let's see, 135 divided by 5. That's going to be 27. And then 180 divided by 5. That's going to be 36. So we get 27 pi over 36, and that will reduce again. So 27 divided by, let's do 9, that's going to be 3 pi. If we divide by 9, that's going to be 3, and that's going to be 4, so you're going to get 3 pi over 4. Alright, so let's do this one. So you have pi over 180. Obviously the zeros are going to cancel out, so let's do again 330 divided by 30, and that's going to be 11. And let's do 180 divided by 30, and that's going to be 6. So this is going to be 11 pi over 6. And that's how you convert from degrees to radians. Okay, so let's look at these. Convert each degree measure to radians. Well, remember here it said if decimal degrees or degree minute seconds is given, then you're just going to use 3.14 or pi to find the decimal answer. So for example, here, if you have 85.4 degrees, you notice that we can't readily reduce the 85.4 and the 180 like we did earlier. So what we're going to do is we're actually going to do 85.4 times 3.14, or if you want to use the pi button on your calculator, and then divide by 180. That's going to be and we'll just round, 1.49 radians. And so if you start with a decimal degree, or if you start with degree minute seconds, then your answer is going to be in decimal radians. Okay, so same thing. We're going to do pi 180. And so in my calculator, I'm going to do 35 degrees, 25 minutes, times pi, divided by 180, and you're going to get 0.62 radians. Now, why am I using the word radians here instead of here? I just had answers in terms of pi. Well, here I left my answer in terms of pi, and when you have an answer in pi, it's understood to be radians. That is the unit for radians, I guess. But here we are actually multiplying 3.14 or pi actually into our answer. And so when we're using pi or 3.14 and to get this decimal, we need to write radians, because we don't know if this is decimal degrees or what unless we write actual radians. And since we used pi, it is going to be radians. So again, we're going to multiply 125 degrees, 15 minutes, 30 seconds by pi over 180, and we do that, we're going to get, we're actually going to use the pi, and so we're going to get 2.19 radians. So again, if you actually use pi in your calculations and come up with a decimal, then you're going to need to write the word radians. And if you don't use the pi, in other words, you leave it in terms of pi, you can just reduce and get a whole number here, or a fraction rather, then just leave it in terms of pi, and that's understood to be radians. Okay, convert each radian measure to degrees. Well, this time we want pi to go away, so we're going to do 180 over pi. We want pi's to be diagonal to each other, and then when we can reduce here, so 6 will go into itself one time, and 6 will go into 180 30 times, and so you're going to get 30 degrees. So pi over 6 is the same as 30 degrees. Same thing here. We'll do 180 over pi. Pi cancels out, and then we can reduce 180 divided by 4 is going to be 45 degrees. And then if we multiply 45 times 5, we're going to get 225 degrees. Okay, and then the last one, again, get rid of pi. So pi's will cancel out, 3 will go into 180 60 times, and then if we multiply 7 times 60, we're going to get 420 degrees. So going from radians to degrees, you're going to multiply by 180 over pi so that pi's will cancel out. Convert each radian measure to degrees. Now remember, this is understood to be decimals, and the reason being is because this answer has actually 3.14 or pi in it. So we're going to transfer or convert this to degrees, so our answer is going to have a decimal in it. So 5 radians, we want it in degrees, so we need degrees on top, 180 degrees over pi. And remember, it has pi, this number here has pi in it. Alright, so we're going to do 5 times 180, and then we're going to divide by pi, divide that pi out because this has pi in it, and we're going to get 286.48 degrees. So same thing, we want degrees on top. And since this 3.65 has pi in it, we need to divide that pi back out. So what we're going to do is we're going to do 3.65 times 180 degrees, and then we're going to divide by 3.14, or in your calculator just divide by the pi button. Anyway, you're going to get 209.24, and again we are rounding, degrees. Now I use 3.14 instead of the pi button because I'm just using a basic calculator, so the degrees, the decimals rather, are going to be off a little bit. So if you actually use the pi button instead of 3.14, you are going to get 209.13. And so most of us have the scientific calculators, and so you're probably going to get this answer instead of the 0.24. Again, if you use 3.14, you're rounding, whereas if you use the pi button in your calculator, you're not rounding until the very end. So it is going to make it a little bit different. Okay, so here you have 180 degrees divided by pi, and so you have negative 3.456 times 180. Divided by your pi button in your calculator, and you're going to come up with negative 198.01. So that's how to convert radians to degrees. And again, if you have pi in your answer, they just cancel out straight up. Whereas if you're dealing with the decimals, they're not going to cancel out because we don't know if this is, well, we do know this is rounded, and so you actually have to divide the pi out. And I would suggest that you use the pi button on your calculator so that you come up with the appropriate decimal degrees and then round to the nearest hundredth at the end. Alright, finding exact values. Remember, exact means that we don't want our calculators. So, I mean, you can use your calculator for reducing, but other than that, no. So you can find exact values of trig functions with radians if you change the radian measure to degree first. Now, most of these you're going to have done these enough to where most of these you know right off the top of your head. But if not, we can figure this out. If the denominator of the fraction is 3, 4, or 6, it can be very easy to calculate the reference angle. And the reason being is because with the 3 and the 6, we're dealing with a 30, 60, 90 triangle. And with the 4, we're using the 45, 45, 90 triangle. So let's look at this. Find the exact value of sine pi over 6. And if you put that in your calculator, you're going to get a decimal, and we do not want that. So what we're going to do is we're going to turn pi over 6 into degrees. So we want degrees on top. Pi's are going to cancel out. 6 will go into itself one time, and this will go 30, and so you're going to get 30 degrees. Well, going back to our 30, 60, 90 triangle, we know that we get 1, 2, radical 3, and sine is opposite over hypotenuse. Sine is opposite over hypotenuse, so sine of 30 degrees, sine of pi over 6, or 30 degrees, is the same as opposite, which is going to be 1, over hypotenuse, which is 2. So you get sine pi over 6 is the same as 1/2. Again, if you don't know where pi over 6 is, if you don't know that pi over 6 is the same as 30 degrees, convert your radians to degrees, and then hopefully you'll be able to use your 30, 60, 90, especially if your radians have a denominator of 3, 4, 6. Alright, so cosine of pi over 6. We just did that conversion, but we'll do it again. Pi over 6, converting it to degrees, we know that that's going to be 30. So cosine of pi over 6 is the same as cosine of 30 degrees. And again, if we draw our 30, 60, 90 here, 30, 60, 90, we have 1, 2, radical 3. Cosine is adjacent over hypotenuse, and so we're going to get radical 3 over 2. Again, be careful with the quadrants because you know the signs of the quadrants now, A Smart Trig class. But here we're in quadrant 1, so everything's positive. Here in the previous problem we were in quadrant 1. 30 degrees is quadrant 1, so that's going to be positive. Pi over 4 is still quadrant 1, and I know that because pi over 4 converted to degrees, and like I said, you do this enough and you're not actually going to have to do the conversion because you're just going to know it. So this is going to be 45 degrees. So we're doing cosine of pi over 4 is the same as cosine of 45 degrees, and you know that we have a 1-to-1 to radical 2. Cosine of 45 degrees is adjacent over hypotenuse, and so you're going to have 1 over radical 2, but we need to rationalize that, so that's going to be radical 2 over 2. And again, you're going to do this enough to know where you know cosine of pi over 4 is the same as cosine of 45 degrees, which is going to be the same as pi over 2, or radical 2 over 2. Okay, 5 pi over 6. 5 pi over 6 carries us outside of quadrant 1. So let's see where that takes us. It ends in 6, so I think it's going to have a reference angle of 30. Again, that's the hint that I was telling you up here. If it has a denominator of 6, then it's going to have a reference angle of 30. 4 is going to have a reference angle of 45, and 3 is going to have a reference angle of 60. Okay, so let's look at this one. So if we reduce this, that's going to be 1. There's your 30, but you have to do 30 times 5, which is going to be 150 degrees, which tells you which quadrant you're in. So you're actually going to be in quadrant 2, but you do have a reference angle of 30, and I'll show that to you. So we're here, 150 degrees. This is your 150, but remember we have a reference angle, theta prime, of 30 degrees. And so really we're looking for tangent of 30 degrees. Well, we have that on this triangle up here. Tangent of 30 degrees is going to be opposite over adjacent, so that's going to be tangent of 5 pi over 6 is going to be negative because we're in quadrant 2, and remember sine and cosecant's the only thing that's positive in quadrant 2. So it's going to be a negative, tangent's going to be opposite over adjacent, so that's 1 over radical 3, or negative radical 3 over 3. Okay, so let's try this. Through how many radians will the hour hand on a clock rotate in A, 12 hours, and B, 5 hours? Well, we've already talked about the clock, but let's refresh our memory. So we have 12, 1, 2, 3. And remember, one full rotation, the 12 hours, is 360 degrees. 360 degrees. So if we go 12 hours, one full rotation, that's 360 degrees. So letter A is very simple to do. To convert this to radians, we're just going to do pi over 180 and then reduce that, the 180 and the 360 will reduce to 180 will go into itself one time, 360 two times, and so we just get 2 pi. So we know that one full rotation is 2 pi radians. But if we do B, we want 5 hours. So 1, 2, 3, 4, 5. Well, remember, if we do 360 divided by 12, 360 divided by 12, that's going to be 30. Okay, so we know that each hour is 30 degrees. Well, we want 5 hours. So we know that we're talking about 150 degrees. So if we convert 150 degrees to radians, we're going to have pi over 180. And then if we reduce that, we reduce by 30. That'll go to 5, that'll go to 6, and so we're going to get 5 pi over 6. So for 5 hours, you're going to go 5 pi over 6 radians. Alright, so what I'd like you to do is I'd like you to try these problems on page 106 and 107. If you have any troubles, bring them into class.